Hi everyone, my name is Mudawat Lakshman from third semester section F Computer Science and Engineering. So today I am going to explain about design and implementation of an adaptive feedback queue algorithm over openflow networks from the subject data structures. So we'll move to the first slide of the introduction part of queue management in openflow networks. Queue management is essential for maintaining network performance and fairness. OpenFlow enables programmable control of network devices, including queue configurations. Adaptive feedback queue algorithms dynamically adjust to network conditions, improving efficiency. So here, queue management is a fundamental aspect of networking because it ensures smooth traffic flow, fairness among users, and overall stability. In flow, in OpenFlow based networks, which are part of software defined networking, we can programmatically control how network devices handle queues. So this is introduction part and we'll move to the next slide. So it is motivation and challenges. So traditional queue algorithms often lack responsiveness to real-time network congestion. Open-flow networks require flexible, scalable solutions for diverse traffic patterns. Design an adaptive queue algorithm involves balancing latency, throughput, and fairness. So here, traditional queue management algorithms like FIFO or RED are often rigid and do not respond effectively to real-time congestions in dynamic networks. Open-flow networks, however, deal with diverse and unpredictable traffic patterns such as video streaming, IoT data, or cloud applications, whatever. So these are flexible and scalable queue solutions. So the challenge is designing an adaptive queue algorithm is to strike a balance between reducing latency, maximizing throughput, and ensuring fairness among all data flows, even under heavier busy traffic conditions. So these are the motivations and challenges of adaptive queue management. And let's move of overview of OpenFlow and its role in queue management. So what is OpenFlow first? OpenFlow provides a standardized interface for controlling network switches and their queues. OpenFlow provides a standardized protocol for communication between the controller and the switches in a network. This means that it can dynamically modify queue parameters like buffer size or scheduling priorities based on network conditions. It allows for dynamic modification of queue parameters based on network feedback. So the OpenFlow allows dynamic modifications of queue parameters based on network feedback. And when combined with adaptive queue algorithms, OpenFlow enables intelligent traffic management that can ensure quality of service. QoS, essentially OpenFlow serves as a foundation that allows us to embed adaptive feedback mechanism into a network in a programmable and scalable way. So proper integration of queue algorithm enhances traffic management and quality of service. So this is the overflow of OpenFlow OpenFlow network in a queue management. Next, we'll go to concept of feedback in queue algorithm. What is feedback in queue algorithm? So feedback plays a central role in adaptive queuing. Okay, feedback mechanisms are monitor network conditions such as congestion and delay. So by continuously monitoring network matrices such as queue length, congestion levels, packet loss, and delays, the system can understand the real-time state of network. They enable queues to adapt dynamically by adjust their parameters. The feedback loop then uses this information to adjust queue parameters automatically, ensuring that traffic continues to flow efficiently. Effective feedback loops are crucial for maintaining optimal network performance. Without an effective feedback system, queues either overflow or remain underutilized, leading to poor network performance. And design goals of adaptive feedback algorithm. So what are the design goals of the adaptive feedback queue algorithm? So the primary design goals are minimize packet loss and buffer overflow during congestion, and adapt quickly to changing traffic loads and patterns, ensure fairness among multiple flows while maintaining high throughput. So here the primary design goals of adaptive feedback algorithm are threefold. First, it must minimize packet loss and buffer overflow during congestion periods, which directly improves reliability. And second one is adapt quickly to changing traffic loads. So it means it should be able to quickly adapt to traffic changes such as sudden spikes in data flow. And finally, the algorithm should guarantee fairness so that no signal flow dominates the bandwidth, all while maintaining high throughput and low latency. These goals guide the overall development of an algorithm. And let's discuss about architecture of the proposed queue algorithm. Yeah, the system includes a feedback monitoring module, control logic, and queue management. Feedback data is controlled via OpenFlow statistics and congestion signals. Control logic processes feedback to adjust queue parameters dynamically. So the architecture consists of three major components here: the feedback monitoring module, the control logic, and the queue management system. The monitoring module collects traffic related data through openflow statistics and congestion signals. This information is then fed into control logic, which decide how the queues should be adjusted. Finally, the queue management system applies those changes in real time. Together, these modules create a closed loop system that adapts continuously to network dynamics. Next, we are going to quick monitoring on feedback collections of monitoring. So here feedback collection and monitoring. So openflow's statistics messages provide real-time data on queue occupancy and flow rates. OpenFlow provides detailed statistics such as queue occupancy, packet counts, and flow rates, which are essential for feedback collection. Additionally, congestion indicators include packet delay and loss matrices. Here, other congestion indicators like packet delays and packet losses are monitored to detect problems early. By continuously gathering this data, continuous monitoring facilitates timely adjustment to queue configurations. This real-time monitoring forms the backbone of adaptive queue management, which is the system can identify potentially bottlenecks before they cause significant degradation in service. So next we are going to learn about adaptive control logic. What is adaptive control logic in queue management? Adaptive queue management. So here the control algorithm interrupts feedback to determine necessary queue adjustments. Once feedback data is collected, the adaptive control logic interprets it and decides how to adjust the queues. And next, it employs techniques like proportional integral derivative (PID) control or machine learning. So here, control techniques such as proportional integral derivative controllers or even advanced machine learning models can be used here. So the main challenge for the control logic is to remain stable while still being responsive enough to react to sudden changes. In short, we can say that the logic acts as the brain of the system, making intelligent decisions for smooth traffic flow. Next slide, we are going to learn about queue parameter adjustment strategies. What are the queue parameter adjustment strategies here? So adjust queue weights and buffer sizes based on congestion levels. So queue adjustment can be done in several ways. For example, buffer sizes and queue weights can be changed depending on the current congestion levels. Next, implement priority queuing for sensitive applications when needed. So sensitive applications such as video calls or real-time gaming can be prioritized through priority queuing. Use feedback to set threshold and trigger queue recognition automatically. So feedback data also helps in setting thresholds where queues are reconfigured automatically when certain limits are crossed. These strategies ensure that the system reacts appropriately to different traffic situations. Next, we move to implementations. How to implement the openflow in a detailed way. So key matrices include average latency, packet loss rate, and throughput. Fairness among flows is measured using matrices like Jane's index. Response time to congestion events indicates the algorithm adaptiveness. Here, implementation details in overflow. In openflow environment, several key matrices are considered when implementing the adaptive algorithms. Okay, these include average latency, packet loss rate, and throughput. Fairness among multiple flows is measured with matrices like Jane's fairness index. Another critical factor is how quickly the system responds to congestion events, which reflects the algorithm's adaptability. These matrices collectively help evaluate the effectiveness of the implementation. So these are the implementation details in openflow, and next we'll go to experimental results and analysis, like how this adaptive queue algorithm is working and all. So simulation demonstrate reduced latency and improved throughput under load. Experimental result and simulation shows that the adaptive feedback algorithm significantly reduces latency and packet drops under heavy traffic loads. Okay, the adaptive feedback algorithm outperforms static queue strategies in dynamic environment. It consistently outperforms traditional static queue algorithm by being more responsive to dynamic network conditions. And the result also demonstrate improved fairness among flows. That is, results show enhanced fairness and stability across diverse traffic patterns. So that's what we are discussing now. The result also demonstrate improved fairness among flows, as no signal traffic stream can monopolize bandwidth. Overall, the analysis confirms that the proposed method enhances both performance and stability in open-flow networks. Next, what are the benefits of these queue management, adaptive queue management in an open-flow network? So, the benefits and limitations of this queue management in openflow network. Benefits include improved network efficiency and responsive to congestion. So the benefits are the adaptive feedback queue algorithm brings several benefits here, including higher efficiency, lower congestion, and improved responsiveness. It ensures that the network adapts automatically without requiring constant manual turning. However, there are some limitations also. Limitations involve potential overhead from continuous feedback collection. So here, however, there are also some limitations. We got an queue management in openflow, adaptive feedback. Uh, Continuous monitoring and feedback collection introduce some overhead in terms of processing and communication. Additionally, the algorithm may require further optimization to handle extremely large scale networks. Future improvements could integrate predictive models using machine learning to further reduce delays. Next, we're moving to conclusion and future work of these adaptive feedback queue algorithm here. So, we're at the last slide now. So, conclusion and future work of adaptive feedback queue algorithm is the proposed adaptive feedback queue algorithm effectively manages network queues in openflow. In conclusion, the adaptive feedback queue algorithm provides a powerful approach to managing queues in openflow based on networks by enabling real-time adjustments. It offers dynamic real-time adjustments that enhances overall network performance. Future research may explore integrations with SDN and software development network and for broader network wide optimization. Here, by enabling real time adjustments, it enhances throughput, reduces packet loss, and ensures that fairness is in a better way or not. The work demonstrates how combining feedback system with SDN principles can significantly improve network performance. Looking ahead, integrating these systems with broader SDN applications and AI based predictive methods will unlock even more efficient and intelligent traffic management solutions. So, this is one of the way of traffic management systems, and we are using it by a queue by called openflow networks. In openflow networks by adaptive feedback queue algorithm. So this is all about adaptive feedback queue algorithm implementation and design. And I've got these references from some of the books and internet. Have searched for this thing and in internet, and have references some books and academics also, and of some seniors. So thank you. This is all about the adaptive feedback queue algorithm.